there once because it's unique. And then Christchurch, there were 2. There were 4 from Hamilton, but it's just got 1 row for each. So distinct is just a way of making all the rows unique. If I go to the distinct and add weight, because everyone's got a different weight, when I run this one, then we're going to get, unless there's 2 people in Auckland with exactly the same weight, it's going to show everything. But distinct can be useful if you just want to show the single version of each thing. So that's the distinct keyword. Are there any questions or anything so far from anyone? Looks like recording stopped again. Damn it. Got 4 minutes of recording. Maybe I'll just record it with an Opto. Sorry, I'll just get this working. I was watching this one. Okay. Okay, sorry about that. some reason Teams keeps on stopping recording, which it means I have to go back and record it again. So I'm recording it on Panopto, which is hopefully more reliable this time. So where did we get to? Someone was asking about distinct. Is it? Yeah. So let's just go back to. So when we produce data from a database, you get lots of different rows of data, and each of these is a different person. Like, so if I put the name back, oops, wrong one, this one, and we can see there's Calvin. There's actually 2 Stephanies, it seems. But each person is 17 and from Auckland, but there are 5 different people, and then there's the whole lot of who are 18 from Auckland, different people. But maybe we just want, so a more realistic one is maybe we just want all the cities. Maybe we're doing a drop-down box, and we just wanted on our web page, we want all the cities that are in the people table. So if I go select city, and order by city, and then do the same here. So we get this list of heaps of different cities. But if for our drop-down box, I mean, we could deal with that in Python, but it'd be really complicated having to look for the change and look for the first one, see when it changes. But if we just use this one, select distinct city from people, then it just gives us a simple list of the cities. So it's just a way of getting only the unique values. But if I add age back in, it's just giving me the unique combinations of age and city. So I don't know how many people there are who are age 19 in Auckland, but it's just giving us once. You probably wouldn't want to do this. It can be useful sometimes just for getting rid of duplicates, but the main one you're more likely to want to do is just this one. So it's just a way of removing the duplicates. So another way of achieving the same thing, that just gives us one of each. But what if we want to know how many people are in each city? That's something we're more likely to want to do. And this is where we can use the group by command. So here I'll change this to group by city. And that shouldn't work when I run it. Oh, it does. So actually using group by city does the same thing. But normally what you do here is you actually want to do a count. So count. So I'll get rid of this one. So if I run that, we've now got the names of the cities, but we've now got a count of how many people are in those cities. So we know there's 11 people in Dunedin, 17 in Christchurch. And we do that with what they're called, these are aggregation functions. So they're things, aggregate means it takes lots of things and reduces them down to one. So count, if I remove group by from the end, and I just go count, then and get rid of city, then it's saying there are 91 entries. Sometimes that can be handy. In your Python, you might be wanting to know how many of something there are, you can just use this. It gives you the count. We can also, there are other things we can do. We can also sum. But in this case, we'll be summing, we have to sum something that makes sense to sum. So like weight. We can also average. Average uses AVG rather than the full word. So we can average age. And we can also use min and max. So this is now going to count. The star just means it counts the whole row, which is what you'll usually use. You could say count age, but it should give you the same result. I think let's just try it. We remember how we've got one null for city. Yeah, see, because one of the cities is null. Null means blank, means there's nothing there. It's different from 0. So when we counted, if we count all the rows, there are 91 rows, but there are only 90 cities because one of them is blank. It means we didn't type in the city. Someone didn't enter a city for one of the people. So that's why you normally count star, because it counts the number of rows. But you can do that. Sometimes that can be useful too. And then we're also summing the weight. So if all of those people were on a boat, that's how much they'd weigh. The average age is that, and this is the minimum and the maximum age. So that's quite useful. If I add in group by city again, then we get it grouped by city, but that's not much use because I haven't said what the city is. So let's just I have to put the city on the front of the list here again. So now it's going to, that's that null I was talking about. So now we can see there are 11 people in Dunedin. In total, they weigh 800 kilograms. The average age, so we can now see the average age by city, or we can see the minimum and the maximum. So that's quite useful. That's grouped by. So we've got some examples that you can work through in the quizzes. But one thing to watch with these group by and aggregate functions is we've added city in here, but if I remove the group by again, then city will stay. And it says Dunedin, so it looks like Dunedin has 91 people, and it looks like the minimum age in Dunedin is this, but this is a trap because it's not actually, this doesn't apply to Dunedin. Dunedin was just the first item in the list. So whenever you use, the minute you put any kind of, if you have a query like select star from, we start again and have select star from people and run that, then we get that. We get 91 rows output, which you can see down here. But if I change this to count star, it reduces the whole thing down to just one entry. So anything else I have here, I can have name, and maybe I can put star even. Which I'm not sure if this works, but we'll see. Yeah, so it's just giving me that first entry in the table, and then it's got count on the end, but the count doesn't have anything to do with this person. So the minute you put one of these aggregate functions in, it collapses the whole query down, and anything else that isn't either in the group by. So in this case, if we have group by city, then we can have city, that's fine. but anything else that doesn't have anything that's not in the group by has to be inside an aggregate function. So here we don't, if we have name and run this, then yep, it gives us oh sorry, that's the other one. So we've got Dunedin, Tommy, Rachel, Fred, but if we go back to this one, so Dunedin says Tommy, Christchurch says Rachel. That's because Tommy is the first one in city. Actually, I won't do the order by. But you can see that Tommy shows up because Tommy's the first entry in Dunedin, and Rachel is the first entry for Christchurch. And that's random. That's just the order that it was entered into the database. So it doesn't have any meaning. So whenever the minute you type one of these types of functions, you need to get rid of everything else that isn't in another. It either needs to be in an aggregate function like this, or it needs to be in the group by. But if it's in neither, then you should get rid of it because it's going to be confusing. So there's just something to keep in mind with group by. But does it make sense how the group by works? It combines them together and like that. And you can group by two things as well. So you can group by age, by city and age, or maybe city and sex. In this case, we can add, if we leave it like this, then we're getting Christchurch twice. And we're wondering why, because we haven't put this other field in there. So we go add sex in again. Let's just run one query. So now we can see Christchurch, females in Christchurch weigh this much. The average weight is this, the average age. So that could be more useful to group by two things like that. And if we can then also add in same thing here. We can order by as well. I need to get rid of that other query. So now it's ordering by in order, so it's a bit a nicer output. So we're adding order by and we're adding order by and group by together. So now we can get in quite a useful output. So if you're wanting to see whether how the weights differ between cities and between the genders in cities, and you can do it that way. If you just want to see whether men weigh more than women, then you could just group it by gender. And then you can see the average. We haven't got average weight, so I'd have to change that to so we can see in this example, see, I've left the city name in there, and that's meaningless again. It's just the first one. So I should get rid of that. And we can see that in our example, the men weigh more than the women, which you'd expect, and so on. If we want to get rid of these nulls, we see how we've got a city with which is null. We can go is not null. Oh, yeah, sorry. Yes, you're right. I think it's null for both, but Yeah, so now it's, so that if you can also get rid of the nulls quite easily, which is, so null is like none in Python. And I think a null comes into Python as a none. So yeah, you can see how we've now started to combine this. We've started to get some useful information which you could use. There's another one we can use. So we could change this back to city. And we just go with count. We'll get rid of that. That one thing I'll tell you now, when you're using MySQL Workbench, to run a query, you use this little lightning bolt thing. And if nothing's selected, it runs everything that's there. And so what's been happening, as you can see, there are two tabs down here. So it's running each of the queries. And but if I just want to run one query, then I can select it, and it only runs that one query. And if I select this one, it only runs that one. And I think you can actually do it so that if you select that, it'll ignore the order by. Yeah, so it's not ordered. So you can select, it just does whatever's selected. This one here, if you're inside a single query, it'll just run that one. So you don't have to select the whole thing. Actually, that's what I should have been using just before. So it's just something to keep in mind. So let's run this one. And now we only want to see the cities that have more than 20 people in them. So if we use a where, we can say where and but that's given us an error, invalid use of group function. So you can't put, so the where can, anything that the where applies to this level. So anything that works within a single row, we can say where ID is this and name is that and weight is that, all that kind of thing. We could even have 2 times the age is less than 4 times the weight. We can do all kinds of things like that because it all works within a single row. But the minute you're working in groups of rows, you have to use what's called having. So down here, we use the having keyword. And having is like where for groups. So it runs after the query, this part of the query runs first, and then, and this part. So it's like it runs that, and then it applies, this is like a where to that thing that you've run. So now it should give me, so now it's just giving me the cities with more than 20 people. So that's how having works. Okay. Okay, so how are we going for time? A couple of other things to show you. If I just go back to, I mean, we can also do things like, while we're having a group, we can add things together. It doesn't mean anything really, but in this case, we could add. Let's make it a bit more meaningful. Yeah, we can add the count and the weight together. So it's given us that. Now that's a bit of an ugly name for the column. So we can then create we can create an alias as calc. So by going as calc, that's now going to be the column header. So now I run it, so it's now called calc. But the thing, so let's get rid of the grouping. Actually, I'll start a new query. So we can just name things like city, name, etc. But we can also and age and weight. So that just runs like that. But we can also do calculations. So we could go weight divided by age equals, sorry, as. If you want to put a space in a name, you have to put it in quotes. I mean, that's kind of a meaningless calculation, but we haven't got much to work with here. But so you can also, you don't just have to list things, you can actually do calculations in SQL. And sometimes you'll get to the point in your code where you have to decide, do I do the calculation in SQL or Python? And sometimes it can be whichever works. Sometimes it's whichever is easier sometimes. So now if I run this one, it's giving me the weight per year. So you can do that as well. And the other thing we can do is we can do aliases with tables as well. So I can go as people as P. Now that doesn't make a lot of sense here. It just runs as before. But the final thing I want to get onto today, and this is kind of the tricky part with the trickiest part in queries. What we've done so far, if you practice it a bit, that's reasonably easy. But over here we have another table. Let's say team. Now in the interface here, a couple of things to note. Over here you have schemas. You may need to click on schema down here to click on schemas. And the one that is in bold is the one that you're going to use. So if I make airline bold, and then I try and run this query again, it's going to give me another error. That's because the schema airline is active. So it means that SQL is looking for tables in airline. It's looking for these tables, but it can't find it. So the easiest thing to do is just to double click on that and it becomes bold. Another way you can do it is to type use comp 636. And then I can run both of them. And that will work. Or another option is I can, from comp 636 dot people. So airline is active, but I can get rid of that. I can still run this query because I've said, no, I'm now saying that it's from comp 636. So it runs again. Sometimes when I'll show you in a minute how to set up some of the databases. When you make changes, sometimes you have to press refresh up here, this little refresh thing. This doesn't apply for what I've done yet, but just remember that that's there. And then with each table, so I'll double click on here again. An easy way to get a select of each table is to just click on this little thing next to it. So we're going to be looking at team. So I can click on that, and you can see it makes an automatic select query for me. select star from comp636.team. So now I can see what's in team. But you'll notice that in people, actually I'm on the wrong one. So that's people done on member. So open member. We've got, this is a different table, which is a better example of a table. The other one's a good simple one to start on, but we've got a similar kind of thing, but each member has a team. And rather than having to type in, and here we've got the details of the team, but rather than having to type in, and the team captain can change, rather than having to type that in for every single member, what we want to be able to do is to join the two together. So let's make a query for the members. And we'll change this to show first name and last name. Right, so we can run that and we get what we expect. And we want to see the team as well. Let's add the team. I think it was just team. Nope. Is it? Member team. Okay, but what if we want to also see the night that team practices on? This is where it starts to get a bit more complicated. So I'll get rid of the comp636 bit here. We can now do what's called a join. So we can go in a join. So we want to join that to the team table. Yeah, it's called team. So go in a join team on. So I'll just complete this. So member team equals team dot team name. Okay. And from the team, we want the practice night and the player fee. So now you can see that every person who's in team A, I can now see the practice night and the player fee, and it's all the same, but it's repeating lots of times. So if I want to change the practice night, I can change it here, and it's now changed for everyone in that query. So what's happening here? So we have in the, let's just show member. So in the member table, we have, everyone has a team name. Some of them are null. Everyone has a team. And so what we then do is we say, okay, so member team in this table has the same matching data to team name in this table. So you can see team A, team B, and team A, team B, team C here. So every time, so for Stephen Manaya, he's in team B, and we know that team B has practice on Tuesday. So when we run our query, it's sorted in a different order. Where's Stephen gone? Even yeah, so let's look for Susanna. Susanna Beaumont is in team A. I've done this right. Yep, so Susanna Beaumont is in team A, and so team A has its practice night on Monday. So in this one, Susanna Beaumont, team A, practice Monday. So it's linking it like that. So the syntax is we create the table the main table we want to start from. Usually that's best to be the one with the most entries in it. So member, and then we type inner join, and then we type the table that we want to join it to. So in this case, we've got all our members, and we've got the team name, and then we've got the teams table over here, and we want to connect the member team field from member. We know that matches up to team name and team. So we go member.teamname equals team.teamname. So it joins those tables together and then repeats them each time. It's probably something to have this one's something to have a bit of a play with. It's a bit more, it takes a bit of getting used to, but once you do it, it's really useful because you can have, like if you've got customers and orders, you can have a table that shows customers and products. You can have an orders table that has the customer ID and the product ID, and that's all you need. Because all of the customer, but if you want to make an invoice with the customer name and the product details, you join those tables to it. So customer ID, you can look up the name, address, and all that sort of thing. Product, you can look up the product name. So that's where the power of that's why they're called relational databases, because you can join the tables together. But that's probably enough to get started on. One other thing to note is you'll see that there are some members don't have a team. So Paratene is so Paratene won't be in this link. It only links the ones that have a match. It only links the ones that have a match. So if we want to show all of the ones, even if they don't have a team, then now most of the time you'll use inner join. If you're not whenever you start out, use inner join. And I see a lot of people using left and right join, but only use that if you specifically need it. You always start with inner join. But if we want to see the people that don't have any team associated with them, then by creating a left join, so the join only finds the people with a match. The left join will give me the names of the people that don't have a team as well. So we can now see these people without a team show up in the list. That could be quite useful if you're wanting to create a list of members and their practice nights. And you also want to see the ones that don't have any team associated. That could be useful. And you can also use a right join if you want to go the other way. I have trouble remembering which is which, so I usually just try it and see which one makes sense. And if it's not that, I do the other one. But that's we see Johannes Chen and Lian Yang are showing in the list. If I make this an inner join, then they're not showing in the list. So that's the time when you use left and right. It's when you want something without a value on one side to still show up. But most of the time, 90% of the time, you'll be using inner join. So whenever you start to do a join, start with inner join. If you think that you need something else, then change it, but start with an inner join. Yep. 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 Correct. Yep. So you have, just to recap what you said, that you have two tables. Both of those tables have something repeated. So let's say it's you. Let's say we have student ID and the course that you're taking, and then we could have, in this course, we just have to have Comp 636 and your ID number, but we don't have to write down your name, address, and email, then your name, address, and email, and then if your address changes, we don't have to change it here, and then for Comp 640, instead we just have ID 123. So in course 636, we have ID 123, and over here we have a table full of students. So we say ID equals 123. We join ID to ID, and we join to the student table, and that student table has all your details in it. And then, so then we can have another table, which is, you could be in a club. Maybe you're in a club, a table, a ping pong club, and then we have member 123, and then we can look back over to here and get your details. And if your address changes, we change it here, and it changes for everyone. So it's kind of like a lookup. If you've used VLOOKUP in Excel, it's kind of like that. It means you don't have to store the value in the same place. Just one other thing to note is that, remember I said you can make at the moment we have member team and team name are different. Often you'll have ID in two tables. If you just say ID, if we just typed ID here, then MySQL is going to say, which ID do you want to show? So it doesn't apply here, but it's usually good practice to actually say the name of the table. So team.practice_night, team.player_fee, and do it for all of them. So then this is useful too when you've got big tables and you come back to it later and you can't remember what table each field is in. So just putting this reminds you of which table it's coming from. But that can get quite long if the names are long. So what you can do is you can use an alias here. So you go member as M, team as T, and then I can just change this to t.practice_night. And then, so then you can, for every field, you can go M dot, and you can see that SQL knows what M means. So it's giving me all the names of the fields in member. So now, if someone comes to this, they know that practice_night is actually in a different table to the others, because you can see the T. So it's just good practice. Usually you can just use a single letter, but sometimes you might have, like for order you use O, maybe for customer order you might have customer order and customer order, so you might have to use CO or something. But usually you can just use the first letter. And it just means that makes it nice and neat. So you go member as M, so then anything with M dot means the member table. Inner join team as T, and so on. So when you're doing the inner join, the key thing, it's kind of, you're starting with one table, so you have to choose a table to start with. Then you type inner join. Then you type the name of the second table, which is team. And then you're defining which fields are we matching up on. So in the example we gave before about student ID, what's the name of the ID field in the class list? What's the name of it in the student list? Sometimes they might just both be ID. In this table, it might be ID. In the class list, it might be student ID. So the names might be different. In this case, the field names are different, but sometimes they'll be the same as well. Okay, so I think that's enough to get going on. Make sure to install MySQL. on the Learn page, back, that there is a link. So under database, if you haven't already, there's the install MySQL in Workbench. I just realized why this query didn't work. In here, there's a connect.py. This is what connects to your database. You don't have to worry about this just yet, but in here, there's a password. And you remember why I said not to make your password anything secret? Is because in here I needed to put my password. That's why the code didn't work. So hopefully now if I go over to right, so now the list books works. So this, you can see it's listed everything from the database. And if I go to loan book borrowers, maybe that isn't working so well, but that's what I did wrong before. So the reason I mentioned that, what reminded me, is that when you set up, hopefully we also, so if you're setting it up now, make sure you remember that password. If you can't remember what your password is, I think we told you to write it down at the time. If you've forgotten, the easiest way is to uninstall MySQL and reinstall it and make sure you remember what it is. So that's why that's there. When you use MySQL Workbench, it will, let's just close it. If you close it, it actually, and it saves the things you have open as well. So if I go back to here, when it opens like this, and you'll have down the bottom here, this you should have a local instance. You click on that, and then all my old queries open up again. Just one other little trap. Okay, sorry, we're a little bit late, but if you need to go, but I'll just show you one other thing quickly. On the Learn page, we've got this folder here to create some of the files with the Comp636 and Northwind databases, and later on for the library example. So I've downloaded this folder to here, and I've unzipped it. And here we have a folder with some SQL statements in it. Now, one thing to watch is if I double click on that SQL file, again, yeah, it opens it in MySQL Workbench like you'd expect, but see here how it says unconnected. It's not actually connected to a database session. So if I try and run it, well, I can't run it because it won't let me run it. So you actually have to either go file open from in here, or you can just you can also just drag it in. And now, so when you download that table, you'll get that SQL file. I can, if I get rid of this, I drop the schema. So now I don't have the comp, just like you, I don't have the Comp636. With nothing selected, I just click on this. And you can see down here, it's run a whole lot of little queries. Just make sure there's no errors on any of those. But now it's still not showing up over here. So this is where remember you have to click the refresh. So click refresh. Now Comp636 is there. Remember to double click on it so it's bold. And then we can do everything we did before. And then the same for Northwind. And in the Northwind example, there are two. So you have to run the structure first, and then the second one. So that creates the tables. And then the second one puts the data into the tables. So you have to run them in that order. So run number 1 first, then number 2 second. And you can rerun these. You'll notice that this one says, if schema exists, drop it. So that means that I can run this again, and it will override. It'll overwrite the one that I had before. And that'll be really useful when you're working on your web app. You might be creating new users or adding data, and your database starts getting messy, and you just want to tidy it up. You can just run this again, and it resets your database with clean data. So you can do this multiple times as well. Okay, so just in summary, so we're now starting to see how we link the Python with the web, now the Python with the database part. We're going to do the linking part a bit later, but the key now we're learning how you get data. Python is going to send an SQL. How do you send an SQL to get what we want out of the database? So that's what we're looking at now. So what you need to do next is go to the database section, database learning module. Make sure you've installed the software. This is where the basic videos are for doing this for SQL. And then this is where you download those folders. And these are some quizzes which you can do. And this is about the Python database integration. So that comes a little bit later. But if you want to install the MySQL connector, it's got the command that you use for that. But for now, I think you'll be busy with that. If you want to install that library application, that is here under web applications. So what I recommend now is go away, install the app, download those Comp636 and Northwind databases, run them in SQL Workbench the way I showed you, either going file open or dragging it. Don't double click because it won't work. Open it up, click on the little grey thing. When the application opens up, you'll have to click the little grey thing to connect to your local database, and then you can start going through the exercises and just learning. It's just like with Python, just try it. Just like I did here, try select star from people, then add a where clause and build it up, and you'll get some familiarity. Probably the toughest one to get used to is that inner join, but we can go over that again. But yeah, are there any questions from anyone? Nope. Okay, we'll see you next week. Thanks. Yeah, I'll see you soon. Yep. Yep. You're an international student? Yeah, I'm not. I think you have to do a full-time load. Is that correct?
Yeah.
Oh, are you enrolling in Comp639?
6 and 640.
Yeah.
This is the first semester.
Yeah. There was an email that came out from Stuart about doing Comp639 over summer. Did you get that? Yeah. Yeah, I'll just, because normally we don't run Studio Project over summer, so you have to wait until semester 1. And because you're an international student, you have to do full-time study, and you can't do full-time. So I'll just have to check with Stuart what the what the story is with that.
Send us an-
Yes, send it to compute, and I'll check with Stuart. And I'll, yeah.
Thank you.
Into Excel, did you say? Yep, I'll just stop sharing. All the technology gets a bit confusing. Where are we? There we go. Stop presenting.
Okay, and so it should be grouped together with book, isn't it? So it's a family of books. So I need to be able to, you know, come up with some kind of categorization for my talking book. So here, using inheritance, I can say, well, it is a book, but it's a special type of book. So I can say talking book is actually a book, but then talking book has its own specialized field called the playtime. So every book actually has catalog number, purchase date, title, and author, irrespective of whether it's an ordinary book or a talking book, right? But if it is a talking book, it has a special or an additional attribute called the playtime. Okay, so then the way we design it is that we're going to build an inheritance relationship where I will have a parent class called book, or sometimes we refer to it as base class. So in object-oriented, you will see base class, super class, parent class. They all mean the same. That means they are the parent class or the base class. Okay, and then we can have a talking book which is derived from the parent class, and we call this the subclass or the child class. Okay, so we are saying that a talking book is a book, but a talking book, on top of having all the properties of a book, it has its additional property of playtime. So now we can distinguish between an ordinary book and a talking book, right? An ordinary book will be just a book, right? It doesn't have this playtime. Playtime will have additional attribute called playtime. And obviously you can introduce more methods here that will relate to specific methods related to talking book. Okay, so a derived class will inherit all the properties and methods of its base class. That means here, talking book will get all of that. Okay, talking book will have a catalog number, purchase date, title, author, and info method. Okay, and then on top of that, it has its own additional method and attribute. Okay, so that's what I said. And why have I gone to the end? What? Okay, so when you have a derived class, you can also add additional properties and methods. So we have added playtime. Okay, so here we can now define a talking book, assuming that you've already defined this. Yeah, so we've already defined book, which has all of the attributes that we talk about. And so now we're saying, because talking book is a kind of book, I want talking book to be derived from the class book. And so the way to implement that, or when you write your class definition, is just to put in this book in bracket in class. So that means you're saying a talking book is a book. You know, my base class, the base class for talking book is book. And so here we have the constructor, which a talking book will then have a catalog number, publication date, title, author, as well as p time. So you still need to supply all this information in your constructor. Okay, because remember, a talking book is a book, so it has all of the book attribute plus its own. So this is the book attribute, and this is the additional attribute for the talking book. Okay. And so we're saying, okay, now this is my own specialized attribute. I'm going to set it to p time. And because these 4 is attributes for an ordinary book, I'm going to make use of the book constructor. Okay, and the way we call it is just this, the book dot underscore underscore init underscore underscore, and then you pass. So it's like you're asking your parent to create that object for you, right? And so that will set the number, p date, title, and the author for that particular object, and then with an additional attribute. Okay, and then you can, on top of that, you can define your own, or the talking book owns method called time info, where you can. So here it's just returning a string that says my playtime is that long. Okay, so these are the additional property. So p time is the additional property, and time info is the additional method. So how do we actually use this? Okay, so when we then create an object of talking book class, so remembering this inheritance diagram, talking book will have 1, 2, 3, 4, 5 attributes, right? And then it will inherit 1 method from the parent plus 1 more of its own. Okay, so it has so 4, 1 plus 1 public method and 1 public property and 1 public method. Okay, so that means this one has more, that plus that. Okay, so then how does it work now? So let's say, so now we know that talking book will have 2 methods. Okay, one is called info and one is called time info. So time info is defined in the talking book, and info is defined in the base class. So if we call it, okay, when it says so when you call, okay, after we have created this object, we call talkbook.timeinfo. So what happened is that it will first check whether this method is actually available in the class itself, in the class talking book. If it finds it, it will make use of that method. Okay, so because time info is defined here, we'll immediately make use of this. Then the next one is when it tries to call info. Okay, so you say talkbook.info. Notice that it's not there, right? There is no method here called info. So because Python knows that you inherit from the parent class book, so what it will do is it will go up 1 level, look at the definition of book, and see whether there is something called info method. If it is there, then it will make use of this method. Okay, so there is what we call an indirection where, you know, let me find it in the actual class. If it's not there, you know, I'm going to go up to the parent and see whether there is one. If there isn't, then there will be an error. Okay, so sometimes you can have multiple inheritance or a hierarchical inheritance where, you know, A can inherits from B, B inherits from C, so it will just go up until you get to the top, and if you can't find method, then you'll get an error. Okay, okay, so this is a situation where this is defined in the base, this is defined in the actual class. Right, so when you want to present the information for talking book, you may need it to be different from the parent class, right? So you want it to be different. So we may want to override the method of the base class so that you can then have your own info method. So the class itself have your own info method. So this is what we call, what we refer to by overriding methods. So we know that there is already an info method of the base class. But if I use info method of the base class, it will only give me the 4 properties, right? The catalog number, the publication year, and the other 2 information. So let's say actually what I want is I want to add the playtime as well. So I don't want to use info. Well, I can actually, because I can write another method in So I can actually put here, right? I can actually use this and say the catalog number is this, the publication date is this, the title and the author is this, plus the playtime is this. I can do that, right? By using this. But alternatively, I can override what was already defined in my base class, which is the info method. And so we override the method of the base class, and all we do is we redefine it inside the talking book class. So we define in the talking book class another method called info that does this. So what's happening now is that now you have 2 methods in the talking book. You have info, what is that? So you have time info, and then you have just the info. So when you do this, the base method is now hidden, right? Because you can't actually call it now. Because the first thing it will do when you do talkbook.info, it will check in its own class, and it finds that it will then display this one. It will then execute this method. So it's not going to go up and find that info because you have already overridden that method. So some of you might say, okay, but what if I want to use the info method of the base class? What do I do? Well, you don't have to name it differently. You can use the keyword super to say, I want to use my parents' info, not my own info. Okay, we'll see in a minute. Yeah. So we will qualify this and say, so in fact, I can put here, call the info method of my parent, and then I want to add my own additional information, right? That will make it easier rather than having to say this. So the info method has all of the information about ordinary book. So actually what I really want is to make use of that info method in my info here, in my overridden method, then add the additional information. So actually the way to do this is to use the keyword super. Okay, I'll show you in a minute. Okay. So now what happened is that you have an info there, and you have your own, the talking book has its own version of info, and this is not inherited from book now. This is overridden. You've override the info method. So like I said, just remember that. Now that one's not accessible unless you use the keyword super. Otherwise, it will make use of whatever you have defined here. Okay, so now we have two types of object, right? You can either have an ordinary book or you can have a talking book. So you can create a book, okay, and we know how to do that. We can create an a book object. We can create a talking book object. So if we create an a book object, if we do a book.info, then it will make use of the book info method, right? If we use talkbook.info, it will make use of its own info method. Okay, so if you do that, you'll get that. Otherwise, if you use it for talkbook, it's like that. But we are both calling the same method. Well, method with the same name. Okay, so inheritance provides code usability. As you can see, you don't have to rewrite some methods. You can just, if you inherit from your base class, from your parent class, you just need to reuse it. Okay, so use the existing class to create new class instead of creating it from scratch. And the good thing is that the child class can access all the data and the methods defined in the parent class. And they can even have their own additional data and methods. So you're saving a lot of efforts in writing the codes again. So you don't have to repeat the code again. And child can also provide specific implementation to the methods of the parent. So if there are methods of the parents that I've already inherited, but the child doesn't like that method and wants to redefine it, yes, you're able to do that using the overriding method or overriding concept. Okay, so what sort of inheritance can we have? So we can have single inheritance. So this means you have one parent class, and then the derived class is derived from a single base class. So that's called a single inheritance. So in this example, we have animal, and then dog inherits from animal. Okay. So here we define speak, and then we define bark for dog. So that means dog class will also be able to have to access the speak method. Okay, so if we define a dog, we can say a dog.speak. It will, because it's not available here, it will make use of the parents method, and then we can use our own, and then a dog can use its own local method. That's single inheritance. Or in Python, you can have multiple inheritance. That means your derived class, the child class, can actually inherit from more than one base class. So you can have two parents, which is really neat because you can actually, model parents, So here we can have a mother and a father, and the son inherits from mother and father. And the way we do it is just specify mother and father. And then so we can then say a son, and then when you do a parent, goes here, display the father, display the mother. So that's what we mean by multiple inheritance. And then we have multi-level inheritance, where you have a base class, and then you have an intermediate class, and then you have a derived class. So this is like, grandfather, father, son kind of situation. Okay, so here we have a grandfather. So you need one value for the grandfather, which is the grandfather name. And then you have father, which inherits from grandfather. So you need the father's name and the grandfather's name. But actually, to set the grandfather's name, you just call the grandfather's constructor. And then you have son, which has father, and you need to supply all three values, such that you can then invoke the full name and get the whole thing. Is this okay? Does that make sense? Any question? It looks very simple, right? But actually, when you implement it, then sometimes it's not that easy to implement. This is a very simple example, so it's easy to understand. Okay, then you can have hierarchical inheritance. So this is where you have a base class, and then you can have many derived class. Okay, so that means if you think of a parent-child relationship, a parent can have more than one child, right? So child 1, child 2, child 3, and then remembering that child 1 inherits from parents, child 2 inherits from parent, child 3 inherits from the same parent, but then each of these child may have their own specialization. You know, may have their own additional method and additional. They need not have the same, same setup. This can be a different class, a different class, a different class, but all three of them are related by the parent because all of them are derived from the parent or the base class. Well, what happened to my polymorphism? Oh, I'm not there yet. Okay, right. So, so that's inheritance. A very simple concept, but the idea is that you want to be able to reuse some of your codes and not having to repeat what's already there. So if we think of a bank account, and we have seen this before, a bank has several different accounts. An account have a number, an owner, and a balance. All accounts have withdrawal, deposit, and interest method. Ordinary account pay interest of 6%. Check account pay interest 6%, only on amounts over specified value. Investment account pay interest of 9%. Withdrawal fee is 20. So how do we set up an inherited class to do this? So we've built this before, but we had three different accounts, three different classes, right? We have checking account class, investment account class, and ordinary account class. So now with our inheritance knowledge, how do we now build design our class so that we can make use of inheritance? So think about the base class and think about the derived class. So all accounts have a number, an owner, and a balance. So that means any account, irrespective of whatever type of account it is, it will have those information, and it will have withdrawal, deposit, and interest method. Okay. So how do you calculate the interest? Well, it depends, right? If the interest, if it is an ordinary account, the interest is 6%. If it is a checking account, you only get interest on amount over 2,000. If it is an investment account, interest 9%, withdrawal fee is $20. How do we write this? Shall we give it a go? Or shall I leave it to you? Well, no, because we're going to look at it again. So let's just open Visual Studio. So let's just create a new Python file. Okay, and I'm going to say, oh, so maybe I should just go to, that's fine. Okay, I'll just do a save as. And I'll go somewhere where I am. Okay, I'll go to my electoral. So I'm going to call it bank inheritance. Okay, so we know what our ordinary account is, right? So let's start by just coding. Where are we? This one has different accounts, so we can create a class and we call it just a bank account. And what do we need? We need an init, and I'm not going to use private, we'll just do public for now. So what information does the bank need? Oops. So what do we need? What data do we need? Or what attributes? Number, owner, and balance. Okay, so account number, account owner, and balance. Okay, and basically what we're saying is self dot account number is equals to ACC num self dot account owner, just to be consistent here, equals to owner and self dot account balance equals to balance. And we need, do we need interest rate? Do you think interest rate should belong to the base class, or do we need to have it for each one of the class? Okay, so here we're saying ordinary account pay interest of 6%, and this one here is 9%. So does it really matter where the interest rate is? Because every bank account has an interest rate, right? Okay, by default it will be 6% if it's an ordinary account, but you can change it. Can you not? You can, right? So can we just add another one? And we'll think about what we're gonna do with it later. So by default, we're just gonna put it at 6%. Yeah, well, not 6, but 0.06. Right? Okay, so now what methods do we need? So we need withdrawal, deposit, and interest method. So we do the withdrawal, which is easy. Well, let's do deposit first. For deposit, we need some amount. And so basically, we're just saying self dot account balance is now equals to self dot account balance plus the amount, right? Okay, and then we do withdrawal. So withdrawal. So let's assume that. So withdraw. So self, and then I'm going to specify the amount. And basically, what we're saying is if balance a self dot account balance, if there's enough money, okay. So what condition do I need to put? If self balance is greater than or equal to the amount, then you want to allow that transaction, right? So what is that? Self dot account balance equals to minus amount. Else, well, you're not going to allow it, so just forget about that. Well, I would argue that, you need to return the status, that will tell me whether that was successful or not. So you would say return 0 or return 1, but just to simplify this, we're just going to do this. So if you try to withdraw, it doesn't change your balance if you don't have enough money. Okay, so what's the other one? The interest, calculate interest. Do I need the interest rate? I don't, right? So basically self dot ACC balance is equals to self dot account balance plus whatever interest rate I get. Multiply by interest rate or self dot account interest rate. Is that right? So that's just updating my balance based on my interest rate. Okay, and by default for an ordinary account the interest rate is 6%. So that's our bank account, and we're saying that we're gonna create another account called checking account, which will be derived from the bank account. Okay, and the only difference here is that so the withdrawal and deposit should be the same, right? The interest rate should be the same because it's 6%. The only thing that's different is how I calculate the interest. So what do I need to do to my new class? What other information do I need to add to my new class? What I can do is actually just override how I calculate the interest, and everything else remains the same. Is that right? So that means I don't have to write much for my checking account. So if I now create another one, class. Okay, let's just close that because that's getting in the way. So class check in the bank. I want to do any new thing that I need to find. Oh, it self, but I still the process, right? And need that, but basically, do anything extra because I have new yet. All I need to do is get the bank account to do the initialization. So I go bank account dot init, and I just pass the 3 values, right? That's it. Yeah, that's it for my constructor. And the other thing I need to do is to then redefine how I calculate the interest. So I'm going to override how I calculate the interest. Here, I'm just going to copy that. Okay, so what changed? So I need to have an if statement to check if the balance is over. So 2000. Okay, so if self dot account balance is greater than or equal to, what have I done? Yeah, if self account balance is greater than or equal to 2000, then the balance will be the same, right? Otherwise, no interest. So don't need to do anything. Okay, so that should be fine. That's all for my checking. Yeah, but if so, the interest rate is already set to 6% because the parent class has set it to the default value 6%. So basically, for the checking account, you will only get an interest if your balance is above 2000. So if you have less than 2000, you don't get any interest. Okay, So that's all we need. So what we're doing is we're just overriding how the interest is calculated, but we're going to make use of the same. So let's just try this. So now let's create, so now we're going to create ordinary account equals to bank account. And let's say, don't know, what information do we need to put? Owner, what's that, account number? So let's say 1001. The owner is Leo, and the balance is 2000. Okay, and we create another one, check account equals to, so now we go checking account, and then we'll provide another account, James, and the balance is 3000. Okay, right, so now we have created. So let's just compile this to see we don't have any error. Yep, missing required positional argument. I think I need to pass self here. When we call, we need to pass self. So that should be fine, so no error. Okay, but what I really want to do is be able to calculate the interest and see the difference. Okay, so here I can say ordinary account dot calculate interest. Okay, and we're just going to print it. And then I'm going to see what happened to my checking account. Go away. Dot. Okay. So that should give me none. Why is it none? Can you see what the problem is? It's to type error, missing one required positional argument. Bank account. Oh, there's another one. I thought I in it. It's very hard to see when you. Okay, and it's saying it's none. I need to see what, let me see what the error is. So it says none. So what does the calculate interest say? Okay, so here we have oh, of course it's not going to return me any value. Why? Any guess? Not really. I'm not printing the rate. I'm not printing the interest. It's just calculating and updating the balance, but I'm not doing anything else. So of course it's returning none because my method doesn't return any value. Okay, so I can go and return here, right? So for the first one, gosh, I hate working with a small screen. And that doesn't, yeah, we'll have a look at that. So okay, I'm just gonna cheat. I'm going to do this, okay, because it's a public attribute. I should be able to print the balance, right? So I can say print. I'll get back to Belinda after this. So self and then we want the balance, right? No, I don't want self balance. I want ordinary account dot, and I actually want the balance, right? And this one here, I want checking account dot, and what's it called? Account balance. Oh, get away. Okay. So basically what I've done is I've called calculate interest, and now I want to see, I started with 2000, right? I want to see what's the balance after. Similarly, I call calculate interest for the other one, and then I want to see what, I want to observe what is the balance. Okay, then obviously they should have different value. Why is there only one value? And now it's complaining? Oh no, it is. So here, is that right? 6%, and that's 6%. That's a lot. Oh no, but we started with 180, right? So 6%, and then 2000 is, 120. So that's correct. Okay, but Belinda, you said if it is a 1000 only, okay, it should not change, hopefully. And why is it not doing anything? Just don't get this. Oh my gosh. Now what happened to my, what is that message? I can't believe this. Okay, let me close this and then restart it again because it seems to be confusing. It's really confused. Okay, now did my Visual Studio just died? Yep. Okay, and I don't, activating extension. Does anyone knows what's happening? Oh my gosh. Yeah, and it's like it doesn't like it doesn't like me demoing while I'm connected to the, oh, there you go, now it's back. Thank you. Okay, let's try that again. It's taking forever. Oh. Okay, is anyone typing? No, hold on, what it's saying that there is something here. Let me get rid of that. I don't know what's going on. I can't believe that this is happening to me. Okay. Oh, it's back. Come on. Okay, we'll try it one more time. Oh, sorry? Yeah, it's getting even. Wow, that's really strange, isn't it? It's taking forever to run it. I don't know why. Shall we just close that? I don't know what's going on. Console, is that the one? Output, terminal. That's what we want. There you go. Oh no, but you're not seeing it. Oh, it say actually what I had on my laptop is 2120 and 1000. So that means that it worked. And so I apology for that, but I'm not gonna carry on with the next one, but I think you know what to do, right? So basically, let's just ignore this because it's so annoying. Apologize for that. Okay, so here, and hopefully it still works. No, it froze. Okay, maybe I unshare my screen and see what happened. Oh, there, yeah, thank you to the fantastic technology. Okay, it's okay. Now let me try and reshare my screen, and hopefully that should work. There you go. So I wasn't lying. Okay, so there you go, 2120 and 1000. And if you want to carry on, and I will leave that for you as an exercise. So I'll upload this piece of code. Whoa, look, it's taking. So here, and now yeah, there's like there's a bit of delay here, but here, if we're looking at the investment account, again, this time around, you will need to modify or override two methods. Okay, one is the interest. So this is where you will, when you create, you're going to have in the constructor, when you create this object, you're going to have to set the interest rate to a different value. Okay, so that means set it to 9% instead of 6. How do you do that? So you call the constructor, you set it to 6, comes back to you, you set it to 9. Okay, very simple. Then the interest calculation, you don't have to do anything because it's just going. So if you change the interest rate, it will do its magic using the base method. But for this one here, you will need to override the withdrawal method. So you minus the balance, and then you minus another $20 for the fee. You think you can work on that? Yeah, you can carry on with that. So let's move on with polymorphism. Okay, so polymorphism, I always like to use the example of, do you know Power Ranger? Mighty Morphin Power Ranger? If you have children, when my kids grow up, they used to watch Power Ranger or Transformers. Transformers can transform into something else, right? From a car into a big giant robot. Okay. So polymorphism is actually a concept where it has the ability, or the object, it has the ability to take different names. So you use the same method name, but depending on which object calls it, it will behave differently. Okay, so you've seen some inbuilt polymorphic function already. Okay, if you use the len function, you can apply it on a string, and it gives you the length of the string. You can apply it to a list, it gives you the length of the list. So it understands that, oh, because you're asking for a string, I will give you the length of the string. Because I'm looking at a list, I will give you the length of a list. So similarly, we have actually also seen a user-defined polymorphic function. So remember how when we pass something to a method and we want to be able to do this, call it with different number of parameters. So we say, I can accept for this method, I can actually accept 2 values, or actually I can accept 3 values. So if you give me 2 values, by default, the third value will be by default 0, or any value that you want. So you're having to call the same method name, but it behaves differently depending on what value you're passing to that method. Okay, so in the same way, we can have polymorphism, and then it takes a while, okay, with class method. So one example, is this. Let's say we have 3 different classes: cat, dog, and duck. And for each class, we define a method called speak. Okay, so cat, you define a speak for cat as meow, and then dog for woof, and then quack for duck. Okay, then we build a list, an animal list. We create an object called cat. We stick it into the list. We create an object called dog. You stick it into the list. Duck, you add it to the list. And then you can go for animal in animal list, animal.speak, and then it will behave appropriately because we've defined the same method name, speak, for each of the class. Okay, so that's the condition. So you must have a common method name so that you can then iterate for every animal in my list. I'll call the method speak. So basically how it works, because animal has different type, and this animal is a different type of object. So it looks at the animal and say, hey, this is a cat object. Now I need to go to cat class and see if there is a method called speak for this object, and it sees that and it will display meow. Okay, goes to the second item. It's a dog. Use the dog speak method, and then the duck uses the duck speak method. Okay, see, that's the magic. So that's polymorphism. Okay. But the other thing is that you can, so that one's without, so this, the one that I've just shown you is polymorphism without inheritance. Okay, polymorphism without inheritance, because all you needed to do was to then define a speak for each one of the class, and they are not related to each other. They are all distinct classes. Then we have polymorphism with inheritance, where again, this is the same example that we have looked at, the book and the talking book, and then assume that there is another class called picture book. Okay, so both talking book and picture book inherits from book. And so here we are creating a list, and then in our list we append a book, talk book, and picture book, and then we can do the same. And remember that there is this info method that we define in the base class, and then in each of the derived class you override the info method to do whatever it is that you want to do. So again, you iterate through the list depending on whether it's a book, a talking book, or a picture book. You get different things. So this is polymorphism with inheritance. So the concept is pretty simple. It says, what is this object? Okay, this object is a book object. Okay, I'm going to go to the book class and run this info method. If it is a talking book, I'm going to the talking book class and check if there's an info method, and then I will display that appropriately. So that, but the requirement is that for each one of these info method in the different classes, you will need to redefine it. You override the base class method. Okay, and that's just polymorphism. Actually, a very simple concept. So now let's go back to inheritance again. So we know, so in the previous example, we were using public public members, right? That means, you know, anyone can actually access the members. But, you know, to actually ensure the privacy of your data, we want to make everything as private. Okay, well, in this case, I have book title as private. And so here, if you do something like this, so you have a book and you have a talking book which inherits from book, and book title here is private. Private means private. That means no one else can actually access the data apart from the member of the class. So even the child, the derived class, should not be allowed to access any private data. So if you try to do this in your talking book, because it's a private data, talking book will not be able to access it, right? And you go, that's not fair, you know, because they're supposed to be related. You know, they're, I don't know, you know, I'm the child. I should be able to access my parents' private data. But no, that's not how it works. Private means private. So how do you do that? So, well, one solution is you can make it public. But then if you make it public now, if you make book title public, that means it's not just the child who can access it, right? It will be everybody else. So there's no special privilege for the derived class in this case. So that's why there is something else called the protected variable. Okay, so protected means that it is available to all the inherited classes, but it will be invisible. So you have this extreme end, public or private. Okay, public means anyone can access. Private means only the member of the class can access this. And then you have, because you have inheritance, we have something in between called the protected, in which if the variable is protected, that means all the derived classes should be allowed or should be able to access that variable. And as I said, with private, when I talk about private, as Python doesn't have, it's not a true, you know, so it's not protected in its real sense, in that it is just notation, you know. So like I said, it's the understanding between programmers to say this is protected, so you know, anyone outside this class or who's not directly related to this class should not be allowed to access it. So to signify protected, we just use a single underscore. So this means that all the inherited classes should be able to access this variable from the parent class. Okay. So as I said, this is just convention in Python. If you have to be a responsible programmer, and if you see this, if you are not part of the class or related to the class, you're not derived class, don't try to access the variable. Okay. So to allow others to access the protected, then we use the getter and the setter, like just what we did with your private. Okay. And so the other thing is super. So remember I said that when you override something, like info here, and you, when you override info, this info will be hidden and you're able to access it. Even if it's not hidden, if the derived class wants to make use of the method of the base class, actually you can use the keyword super. The super in bracket .info indicates that you are calling the method of the parent class. Okay, so just using super keyword. So when you did your when you did this, when we build a constructor, we specify this, right? So the trouble with this is, if I change my base class name to something else, maybe new book, then this one will cause an error, right? Because it's directly referring to that one. So what you can do is take this and replace it with super, because that refers to my parent class. So instead of putting book, you can just put super dot in it. So I don't really care who's my parents. It knows that, you know, for this one, it's the book, so it will go and call the constructor for book. Okay, so it's a more elegant way of calling the parent class. And if the parent class name is changed, the child class is not affected. So use super. Okay, so sometimes you might have this kind of inheritance diagram. You know, your inheritance can be quite complex. So this is where you have multiple inheritance and also multi-level inheritance. So here we have animal, mammal, and then mammal have non-wing mammal, non-marine, and then you have dog. So dog inherits from non-marine and non-wing, and then, you know, you go up the chain, then it's mammal and animal. So the superclass is animal, right? And this is the bottom of the inheritance hierarchy. So how do we actually model that? So we can easily write a Python code to model that. We start with an animal, and then a mammal, which inherits from animal, okay? And then we have non-wing mammal, which inherits from mammal, and then non-marine inherits mammal. And then when it comes to dog, you specify the two parents or the two base class. The only thing is, the question is now what happened when I call dog, when I instantiate an object of type dog? How does which constructor get called first? Because remember, this one has two. Well, it goes here. It starts from here. So you have a super here, right? So super here means call the parent constructor. But in this case, I have two. Yeah, in this case, I have two. So how do I know which order the constructor gets called? So if you think of it as just a single one, then the order is call that, call that, call that, call that, call that. But because there are two here, so there's some rule. So the rule, the constructor calling is based on something called the method resolution order. And what it says is that it should be called in the order it appears. So that means here, if we go here, dog, so you create, so it will print dog has 4 legs. And then when it gets here, now there are 2. So I have to go and call non-marine mammal first. Okay, so it goes here and it will print can't swim. And then I have another one. So now it got there, print can't fly. And then this one now call up, warm-blooded animal, and then animal. So you just have to remember the MRO. But actually, you can print this to see in what order they get called. So here, if you do this, and then you then go print dog MRO, what is the method resolution? It will tell you what constructor get called. So that's the order of evaluation or execution for this. So as you can see, because animal is at the top of the chain, it gets called last. So that's the thing with multiple inheritance. Okay, so for each one of that, you can print the MRO. So the MRO works in a very simplified way. If there are multiple parents, methods of the parent class appears first, will be invoked first. So you go left to right. So remember that you may have, I don't know, this one here only has 2, but you can have multiple, more than 2. So you just need to remember the order. But if you don't remember the order, you can just do this, dog dot underscore MRO. It will tell you what is the order of the execution. Okay. So actually, that was the end of it. So just a question for you to think about. What differences would these ideas make to the bank account example from the last lecture, from the previous the exercise that we did, if we wanted to supply an owner when we created the object? So if you imagine that at the moment, the account owner is actually just a string, it's just a name, which is of type string. But if you think in real world, account owner can be an object, right? Right or not? Because it could be a person object. Okay? So what will change to what we have done if we were to do that? If we are to modify that an owner is actually an object rather than just a string or a name. Any guess? Well, you have to, well, you've done it before, right? You have to create the object called owner of type person, put in, because account owner might have other information like address, email, phone number, and all of that. Create that object first, and then pass that to the constructor of bank account. And that's it, yeah. So then what you have now is another class diagram, which is a person. And to make your design more complicated, a person could be a base class, and a person can be a VIP customer and a regular customer. So you have this additional inheritance diagram that connects to that one. And this is how you're going to build your, sorry, part 3. Part 1 of your project, yeah. So the project 1 will make use of this sort of design where you kind of expand and say, okay, that account has a bank owner, is a bank owner. Sorry, that owner can be categorized into different type of customers. And so you're gonna go person and then VIP, regular, and then you say actually the person is not really, in the context of bank account, a person is really not needed because it can either be a customer or a VIP customer. So there's not a person really. So in reality, you're creating either a customer or a regular, creating a VIP or a regular customer, but you want that person to sit there as a way to generalize the information that you want to keep. So that's why next week we'll talk about abstract class. So that person becomes an abstract class. And so the concrete class are actually the one below it, and those are the one that you want to use. Because you don't really want to create a person, because a person can either be a VIP or a regular customer. So if you think about creating a student, right? I have a student, but the student is actually an undergraduate or a postgraduate, right? So you can't be just a student. You have to be either a postgraduate or undergraduate. And so you don't need to create the object of student. You need to create an undergraduate or a postgraduate student, depending on the class. But I would still want to have this functionality, this generalization. But, I don't want you to create a concrete class out of person or a student. I want you to actually create an undergraduate student. So that's just... because a postgraduate might have different attributes. Postgraduate might have that if you're doing PhD, for example, you have PhD title, you have what year, you have the supervisor name, and some additional information, which is not the same as undergraduate. Right. Undergraduate has major, I don't know what else, CGPA or whatever, So when you see that there are, so usually you will split or recategorize things, have different type of information that goes into it, and then you might in the process you will have additional method.
So some common things that
yes,
yes,
yeah. So when you think about the inheritance, the hierarchy, and whether you can actually categorize things. So just something to think about before you leave. It might be something like this. Like you actually have a person So a person can be a student or an employee, okay? But if but really, if you are a student, you know, you can either be an undergraduate student or a graduate, and really you're creating this object rather than student or person.
Right.
Yeah, but you want to have that kind of inheritance because these are common. A person always have common information. A person has name, a person has date of birth, okay? When it comes to student, you add in the additional information about student, but then when it comes to undergraduate, on top of additional information like student ID and name and, student ID and, you know, the department, as an undergraduate, you want to add more. So you kind of start building some kind of hierarchical inheritance just to see so that when you design your design your class, you think of it as an overall relationship. Okay, so something for you to think about, and we'll carry on next week with this concept abstract class. Any question, by the way? Yes.
The animal and the last class is dog.
Yeah.
And the super white.
Which one here? Is it this one? Here? Is it this example?
Yeah.
So why call super twice?
Because dog belong to.
Okay. So dog inherits from non-marine mammal and non-wing mammal. So here it's calling, and it's not doing an explicit in it. It's calling just a super. So when it says super here, it will look at the relationship here and says, actually, if it's calling super, that means it needs to call two different classes. So it will. So because there are two, it will use MRO to decide which constructor get called first. So it will call this one first, and then after that, then it will then call that one. So that means the super will call this one, right? And then it will print can't swim. Okay. And then here, it will not call this one first. It will go here now. Okay. And then call that one and print can't fly. Yeah. The warm blood. The warm blood is, so it goes back here. It sees only one. There's only one parent class, right? So that's the same call to the mammal. So it's not really doing multiple call. It is, well, it is doing multiple call, but because they are the same, and it resolves, it actually knows that these two is related to just a single. So it will, when the MRO perform this, it will do this and that, and then there's only one super being called up.
So the warm blood belong to which ones? Non-wing or no?
Both, because they both belong to the same group. So non-wing inherits from mammal.
So the order is from first is dog ring, and then fly, and then how the dog parents non-parent.
Because this one here, it calls the super, it goes to mammal. So then it says it's a warm-blooded animal. So you're thinking, can't swim and then immediately warm-blooded, and then this one can't fly and then warm-blooded? No, it doesn't work like that. So if you look at the, so this is how it gets executed. We don't So how it is executed is determined by this MRO. And so the MRO told that this is how the execution should be. Dog first, then do this, then do this, then do this, and then do that.
So if you didn't have the second premise of a non-winged animal that first round,
Then you don't have can't fly
so it would go straight up.
to mammal. So it will be 4 legs, can't swim, warm-blooded animal. It's just that I think here it's a little, so this is where maybe the intelligence comes in, because it sees that both are from the same parent. So it doesn't actually call, I understand what you're saying. It doesn't actually call it twice because it sees that they're both calling the same. So it just resolved that it should only call it once. Maybe if there are branches, like if you think of this one as having another parent class here, then it might jump here and there. But it'll be interesting to see what Python come up, with the MRO. And that is why other languages like Java and C#, they don't have this. They don't have multiple inheritance because it's just too difficult to manage. And so C#, and Java, they only have single inheritance. But you can have, multiple derived classes. But you can only have a single parent because of this complexity. So I don't know, maybe I can't think of any situation where you would use this. But if it does happen, my suggestion is just leave it to Python to work out the method resolution order, the order in which the method or the constructor is called. But I maybe like I said, you might not even get to building or developing something like this. It's always like, a bank account has multiple, a bank account has many different types. So you know that there's only one general class, and you have many different subclasses.
Are you saying this is in our next assignment?
No, not this one.
So this is typing.
Yeah, but in your next, because so what we're doing with your assignment is staircasing. So basically, I'm giving you bit by bit, and now we're moving to inheritance and abstract class and polymorphism. So in your next assignment, where you probably or most likely you will need to use it. I mean, you can still get away without using inheritance, but why would you want to do that if you can actually optimize or make your code more efficient if you use inheritance? That's the whole idea. So remember that object-oriented method have characteristic, which I mentioned at the very beginning of the semester, encapsulation, inheritance, polymorphism, abstraction. So these are the different concepts that you will not find in, procedural programming or some other conventional programming. And the reason why it's there is because, it makes sense to actually design it like that. Any other question? That's good. It's good discussion. Any question about your assignment? Okay, so basically the assignment is to see how you implement model view controller. Okay, and I've asked you to use tkinter because I wanted you to experience a different way of writing program. In your last, we have 4 assignments, but actually the third and fourth assignment is just a single project. So but it's divided in 2 parts. So if you notice in the first 2 assignments, I've given you the structure, I've given you the class diagram and all of that. In the third and the final assignment, you will have to design it yourself. Okay, so that's why I said it's staircasing, getting you ready for doing a small thing and then finally building up your skill. So basically in the first part, so I'll give you the problem, similar to what you have seen before. But you need to think of the class diagram. Okay, so that means just thinking about what are the classes that I need, you know, what are the methods in the class, what are the attributes of each class, how are they related, is there inheritance, is there one-to-many, and all of that. And you submit your design to me, I think after 2 weeks or 3 weeks, and then I'll have a look at it and say, okay, that looks fine. Now you go on and implement it. But remember that you've already got all your methods defined. It's just that you haven't actually put in the actual code. So don't start writing code. Just write the method. So this method will do this. Okay, this method will do that. And then thinking about the model view controller. So you'll have your model classes and then you have your controller. So for the first part of the assignment, you will need to tell me, or you will need to submit the design of your controller and the design of your model class. You don't have to think about GUI at this stage in the first part. And then in the third part, then you actually go and implement it. So no database after all. But in the final assignment, you will, when you implement it, you will have an option. Okay, if you think that tkinter is yucky and you don't like it, you have an option. What's the option? Flask Python, using your web form and your fancy HTML. Because it's still the same, right? So now if you actually think about what we're doing, so what you have been doing with web app is that you have your database, okay? You have your database, right? Your MySQL. That's actually your data model, correct? That's the data model. All the classes, the only thing that's missing is the method, but you know, that's your data model. And then you have your HTML, CSS, JavaScript. That's your view, right? Where is the one that's working really hard to put all the pieces together? It's the controller. That is your Flask Python. So Flask Python talks to the GUI, you know, and then get the information, grab it from the database, manipulate the information, send it back to your HTML, CSS, you know, render it into the nicely formatted information, and that's it, you know. So all the time, your CSS, HTML, does it talk to the database? Never, right? Never. You can't, because CSS, HTML has very limited functionality. Your Jinja receive any list, any dictionary from your controller, and then you display it however you want it. But it never talks to your database, right? It only talks to Flask Python. And Flask Python talks to the database, and it receives instruction from your web form. So it's another concept of model view controller. Except when we're doing OOP, I'm not asking you to actually use CSS, HTML, but in the final assignment, like I said, if you want to play around, you want to be more, if you want to be more efficient, or if you want to experiment with using Flask Python, yeah, that's a choice. But you're not required to use or to build a database, because that's outside the scope of OOP. But if you imagine that you replace your MySQL with the data model, then it's still good enough, right? Okay. All right. Okay. So yeah, we'll see you next week. Thank you. Bye, everyone.